First is 1. Limit x tending to 0. Sin x upon x is 1. Why? Because sin x expansion is your x minus x cube by 3 factorial plus x to the power of 5 by 5 factorial, all odds, minus alternately plus and minus x to the power of 7 by 7 factorial and so on and so forth. Now you divide this by x, you divide whole this by x and take the limit both sides, limit x tending to 0, limit x tending to 0. You cancel x from each part. This is square, this is now 4, this is now 6, and take the limit. So this becomes 1 minus all zeros after that. So you get 1. Now the next is, why is cos x equal to 1? Why is, let's see cos x for cos x. Wait, let's take it down. And now limit, second important limit is limit x tending to 0, cos x. Cos x is 1. Take cos x, expansion of cos x. 1 minus x square by 2 factorial. This is even with x 4 by 4 factorial minus x 6 by 6 factorial and so on and so forth. Take limit both sides. Limit x tending to 0. Take here also limit x tending to 0. Limit, just a minute. Let me write it this way. Limit x tending to 0. These all terms become 0. The rest all terms become 0. So what you are left with is 1. Now let us see why tan x is 1. Tan x by x is 1. Let's see this. Wait a minute. Here, third, limit x tending to 0. Tan x by x is 1. Why? Now you can write limit x tending to 0 sin x upon x into 1 upon cos x. This tan x can be written as sin x upon cos x. Now take the limit inside, in both sides. Limit x sin x upon x and into 1 upon limit x tending to 0 cos x. Right now we saw this was 1. अभी देखा था हमने ये 1 था. Into 1 upon 1 and therefore it is 1. Now next is e to the power of x. Next is e to the power of x. The fourth one is limit x tending to 0, e to the power of x minus 1 a by upon x is 1. Why? Let us see. E to the power expansion is 1 plus x upon 1 factorial upon x square upon 2 factorial, x cube upon 3 factorial, and so on and so forth. Now you do one thing, limit x tending to 0. So e to the power of x, instead of e to the power of x, you write 1 plus x upon 1 factorial plus x square by 2 factorial, x cube by 3 factorial, and so on and so forth. At the end, you write this minus 1. This minus 1 and this minus 1 cancels out. There is an x here. This x cancels out. This makes it square. Now put the limit. So 1, you will get 1 plus 0 plus 1 upon 1 factorial upon 0 upon 2 factorial, and so on and so forth. All zeros after that. So you will get 1. So that's why it is 1 here. Now the fifth important limit. The fifth important limit is this one. Fifth important limit is limit x tending to 0, a to the power of x minus 1 upon x is equal to log a. Now see, you have a to the power of x has a formula of 1 plus x log a upon 1 factorial upon x log a whole square upon 2 factorial, and so on and so forth. Just write limit x tending to 0, you have 1 minus 1 plus x log a upon 1 factorial plus x square log a whole square 2 factorial, and so on and so forth, minus 1 upon x. So you cancel these two. You cancel this x from here, x. This becomes, so you get log a upon 1 factorial plus all zeros. So you get log a, and 1 factorial is 1. So this is log a. Now, similarly, now you can see this. This all limit x tending to 0, tan inverse. This is tan inverse x upon x is also 1. Now, because you put tan inverse x equal to theta, x is equal to tan theta. So you write down this limit if x goes to 0, theta goes to 0. X goes to 0, theta goes to 0, right? From your theta tends to 0. Now you have tan inverse x is what? Theta, and upon what is x? X is tan theta. Now you can write this as limit theta tending to 0, 1 upon tan theta upon theta. This becomes 1 upon 1 because limit in this case is 1, we just saw. So the answer is 1. Now similarly we will see a few more important limits. Limit, limit, let's call it some number. This was a earlier was a part of something. Sixth, earlier was sixth, I hope so. Wait a minute. Just a minute, let me check. Before this, it was fifth. Yeah, this was sixth. This was sixth. This was sixth. And now this is seventh. Now the seventh one is limit x tending to 0 log 1 plus x upon x is 1. Now log 1 plus x means it is 1. It is x minus x square by 2, a plus x cube by 3, and so on and so forth. Now limit x tending to 0, you have x minus x square by 2 plus x cube by 3, and so on and so forth upon x. You cancel this with, and this will be x. The only thing will be left with 1 minus 0 plus 0, and so on and so forth. This will give you 1. Now you have the some more important limits. This is a very important one. This eighth one, log. No, sorry, not log. It is not log. It is limit. It's limit. See, there are two forms in this. 0, 1 plus x to the power of 1 upon x is e. Number one. One way of writing is this. The other way of writing is limit x tending to infinity, x tending to infinity, x tending to infinity, 1 plus 1 upon x to the power of x. This is also either you write this way or you write this way. They are one and the same way of writing. Now you can take log on both sides and do it. Now the thing is this, at times they may give you this limit x tending to 0, 1 upon ax to the power of x. So this will become e to the power of a. Keep this thing in your mind, right? Now we will do certain important questions on limits. Now let us take a question on this application of this. Let us see this question. Let me take more space. Yes. Now see, let us take this question. Limit question. Limit x tending to 0, 1 minus cos 2x plus tan square x upon x sine x, x sine x. The best way is to separate this. This needs to be removed. I told you always. So I will not tell. I'll not tell you what to do. I'll do it directly. Now what I'll do is 1 minus 2 sine square x plus tan square x upon x sine x. Now you can see 1 will cancel, and this will give limit x tending to minus, and minus will become plus 2 sine square x upon x sine x. Now you have plus limit x tending to 0, tan square x upon x sine x. Now the thing is, now you need to break the tan and sine tans into this. See, you have got this. This is tan. Wait a minute. This is tan. This is tan square x. Now you see sine square. This will cancel with this. Take the limit to limit x tending to 0, sine x upon x plus limit x tending to 0, sine square x upon cos square x into you have x sine x. So this sine x will cancel out. So what you are left with, 2, this limit is always 1 into 1 plus this is, see, sin x upon x, limit sin x upon x you have at x tending to 0 and into this one 1 upon limit x tending to 0 cos square x, and cos x is always 1, so this becomes 2 plus this is 1 into 1 by 1, so this becomes 2 plus 1 and this is 3. This is the way you need to do it. Next question, we'll take another good question. Wait, yes, we will take this question. See this one, limit question, limit x tending to a sin x minus sin a upon x minus a. I have told you this formula, sin c minus sin d. So you need to write 2, wait a minute, you need to write limit x tending to a 2 sine c plus 2 sine, no, it's 2 cos, sorry, 2 cos, it is starts with 2 cos, 2 cos x plus a by 2 sine x minus a by 2, x minus a by 2. Now you have x minus a here, right? Now at a this will become 0, at a this will become 0. So see one thing now here, now see one thing, this one, limit x tending to a 2 cos x plus a by 2 into limit x tending to a. Now you have sine x minus a by 2, but you have x minus a here. So what you do is that divide by 2 and you multiply here by 2, and this 2 and this 2 will cancel out each other. So and this whole thing will become 1. Limit x tending to a sine, let me write it from here, wait a minute, let me write it from here, limit x tending to a sine x minus a upon x minus a bracket, this is always 1. So this is 1, so you get put a here, so what you get is cos 2a by 2 into 1, you get 2 cancels out, you get cos a is the answer. Now you have another good question. Let's see. You have another good question. Limit. You have this question. Limit. Question. Limit x tending to 0, a to the power of x, b to the power of x, minus b to the power of x plus minus a to the power of x plus 1 upon x square. Now do one thing. Take bx common here. This and this. Bx is common. You have ax minus 1, you take minus common, you have ax minus 1 upon x square, limit x tends to 0. Now you can factorize this. This is limit x tends to 0, ax minus 1 into bx minus 1 upon x square. So this can be written as limit x tending to 0, ax minus 1 by x into limit x tending to 0, bx minus 1 by x, and ax minus, and this log a and log b. This is log a into, this is x. Wait a minute, this is x. This is x to the power of x to the power of x, and this is nothing but log a, log a. Let me take more space. Wait a minute. Let me take more space. Yes, here it is. So we get this equal to log a into log b. That's all.